Hello dear students, we will see the setting reaction of glass and so we will first see the composition. What does it contains in the powder? That it contains silica, alumina, aluminum fluoride, calcium fluoride, sodium fluoride, aluminum phosphide. The liquid contains 45 to 50% of aqueous solution of polyacids containing polyacrylic acid and its copolymers like itaconic acid, malic acid and tricarboxylic acid. Now all these acids, uh, what what is the role of this acid? These acids have many reactive carboxylic group. Carboxylic group means COOH group, which bonds chemically with the tooth enamel, that is the calcium of the enamel, and dentin collagen, and they form a very strong bond between the tooth and the cement, and this bonding is very strong and it gives a strength to the material. This liquid component also decreases the viscosity of the liquid and tendency to undergo the thickening by gelation due to the intermolecular hydrogen bonding. One more component, that is a small amount of tartaric acid, is also added in around 5 to 10%, which is having a role of increasing working time, decreasing setting time and preventing the thickening of the liquid during the storage. Let's see the setting reaction. As we know, like other cement, this cement also set by the acid base reaction. We can explain it into the 4 steps: dissolution, initial setting, final setting and maturation. All these steps are continuously going on. In the first step, that is when you start powder and liquid mixing together, the acid from the liquid attacks the glass particles and all the ions, that is calcium, aluminum, sodium and fluoride ions gets leached out into the aqueous solution. Means leaching occur during the dissolution step. Now the first step, that is the initial setting. Now during this setting, the polyacrylic acid chain first get cross-linked with the calcium ions during the initial setting reaction, that is within the first 4 to 10 minutes from the start of mix. So there is a formation of calcium polyacrylate, that is calcium salts. Now during this stage, the cement is little weaker, so it can be easily carvable and it gets distorted if it is get moisture contamination. So you will have to coat it with the varnish to prevent the loss of this cross-linking that has occurred. Next step, that is a final setting. Now during the next 24 hours, the gelation occurs when the aluminum ions react with the polyacid chains. The aluminum ions, they are less mobile and they release much later than the initial ions. So as the hydrolysis continues, there is a release of more amount of aluminum and silica ions, and at the end there is a formation of silica gel and aluminum chelate with the carboxylic group. Aluminum also replaces calcium ions because it is having a higher charge as compared to the calcium, and it is having a stronger bonding as compared to the calcium, and this gives more strength to the set cement, and there is a formation of a 3-dimensionally highly cross-linked calcium aluminum carboxylate gel. So how does the reaction? You will have to write during writing in the question the answer sheet. Now the sodium and the fluoride ions, they do not take part in the cross-linking of the cement. Some of the sodium ions, they may replace the hydrogen ions of the carboxylic group, whereas remaining ions along with the fluoride ions are dispersed in the set cement, which contributes for the anti-carcinogenic property. The last stage, that is the maturation, the calcium and the aluminum polyacrylate cross-link chains that we have seen in the second and third step, so they become hydrated with the water that is present in the liquid. So the microstructure, how does it looks? You can see in the center, that is the white part is the unreacted glass particles surrounded by the silica gel, and all these are embedded in the matrix of calcium and aluminum polyacrylate. So in short, we can say that glass powder, that is the powder component, react with the polyacid, that is all the liquid component, to form the polysalt gels and silica gel. Now in this setting reaction, the role of water is very important, as glass anomer cement is a water based cement. Around 11 to 24% of the water is present in the set cement. Initially this water act as a reaction medium and after that it hydrates the cross-linked matrix that we have seen in the last step, that this chain get hydrated over with the time. So it hydrates the cross-linked matrix and increases the strength. So you can explain the role of water in under two heads, that is loosely bound water and tightly bound water. Now under loosely bound water you can write, during initial setting the water is loosely bound. Means initial setting means when there is a cross linking with a calcium occurs. So during that period the water is loosely bound and it can be easily removed by the desiccation when exposed to the ambient air, as we have explained that you should coat it with a varnish. So at this stage it can cause dissolution of the matrix, causing to release the calcium ions from the polyacrylate chain. That means it can be get washed out. So you will have to coat the restoration immediately with the varnish to protect your restoration. Now in tightly bound water, as the setting continues, the same water, that is the loosely bound water, it hydrates the matrix and it cannot be get removed by the desiccation, giving a stable gel structure. Means it cannot be get removed. So this is known as tightly bound water. So this is the role of water setting reaction. Now how the reaction occurs with the tooth. So you will have to explain it, the reaction, the bonding with the tooth enamel and bonding with the tooth dentin. Now as we all know, the inorganic component of enamel is more as compared to the organic component. So when the mixed cement is placed on the tooth enamel, the chemical bonding, that is adhesion, takes place between the calcium of the tooth enamel and the cement component, that is calcium polyacrylate chain get formed by the carboxylic group which is not involved in the setting reaction. Means this carboxylic group which is not involved in the setting reaction, it gets combined or it get cross-linked with the calcium of tooth enamel to form the calcium polyacrylate. So this way the bonding occurs with the tooth enamel. Now in dentin, the inorganic component of dentin is less as compared to the enamel. So the bonding strength of enamel is more as compared to the dentin. Now here how the bonding occurs in dentin. So mainly the organic component of dentin is collagen. So here there are two mechanisms by which the bonding occurs. So in the first mechanism, the hydrogen bonds are formed between the carboxylic group of the polyacrylic acid and the amine group of dentin collagen. And the second mechanism is ions diffusing from the cement allow a cation bridge to be formed between the carboxylic group of the polyacrylic acid and the collagen of dentin. So there is a hydrogen bonding first, and second the ions diffuse from the cement, they form a cation bridge to be formed between the carboxylic group of the polyacrylic acid and the collagen of dentin. So this way bonding of enamel and dentin can be. So this is whole about the setting reaction of the glass enamel cement. Thank you.